Everyone, Mr. Tan here to explain some details about your pre-calc week 5 assignment. I hope everyone's doing well. This week, our learning goal is to understand some things about graphing polar graphs. You can make some really cool graphs with polar equations. So I'm going to start by going over some notes with you. What I'm going to do is talk through this handout a little bit. And if we click on that handout, you will come to this. And so we're going to plot some points for some polar graphs. So normally with equations in rectangular coordinates, it's something of the form y equals something in terms of x. And with polar coordinates, we usually say r equals something in terms of theta. And so we input a theta and then we get out a radius length. So first, as we get started here, we're going to find some decimal values. And what I'm going to do to keep things simple is I'm just going to, I'm going to type some decimal approximations here. So if you type in square root of 2 over 2, you get something about 0.707. Very similar to that, very close to that if you round it. And square root of 3 over 2 is about 0.866. It's 0.866. And all those are for just kind of a way for us to kind of simplify as we plot these radius lengths, because decimal values are a lot easier to plot than fractions usually, or to think about. So what we're going to do is think about a graph of r equals sine of theta, and we're going to graph this by hand. Now, Desmos will allow you to graph polar coordinates and polar equations, but for you really to understand how it works, you really need to plot some by hand, and that's what we're doing first. So if I put in theta equals 0, so sine of 0, if we think about sine of 0, so what I've done is I've pulled up a unit circle here. Actually, in your assignment this week, I have a unit circle. So if you click on the link for the unit circle, and we look at 0. So here's 0 degrees right here. And we think about, okay, what is the y coordinate there? So the y coordinate there is 0. So let's go back to the notes handout. And we know that the y coordinate is 0. So at 0, the answer is 0. At pi over 6, we're going to do the same thing. So there's our equation, sine of theta. So sine of pi over 6, and again, if we go back to that unit circle, at pi over 6, we can see that the y-coordinate is a half. So we're going to continually work up across the unit circle, or going around the unit circle looking at these y-coordinates. So the next one is, what is the sine of pi over 4? So the sine of pi over 4 is square root of 2 over 2, which is 0.707, etc. So I'm going to fill some of these in for us as we work through this. So the first one was 0.5, the next one was 0.707, and this is why we did these up here, so we can just quickly type in those decimals. So the sine of pi over 3 is square root of 3 over 2, which is 0.866 approximately. And pi over 2 is 90 degrees. So let's look at that. So 90 degrees, what is the y-coordinate there? Ooh, it's 1. So we're going to write, or we're going to, in your notes, you would write, and I'm going to type 1. And then if we go to 2 pi over 3, same idea. So 2 pi over 3, what is the y-coordinate there? Square root of 3 over 2. You can see there's a nice symmetry here. So we can see that, oh, the y-coordinate there and the y-coordinate there are the same. Oh, the y-coordinate here and the y-coordinate here are the same. Pretty cool. So I'm just going to keep filling in a lot of those same y-coordinates we already saw. So 0.866, 0.707, 0.5, and then if we get down, oops, timeout, got to go back. Okay, so we go down to pi. The sine of pi is 0. And then if we keep going here, at 7 pi over 6, so let's look at that. 7 pi over 6 down here. What is the y-coordinate there? Ooh, negative a half. So you could see that we're going to see the same y values down here that we saw up above. The big difference is they are negative. So you're going to fill in all of those negative values in your table values. So we're going to have negative 0.5. Oops, I got to try that again. Negative 0.5, negative 0.707, negative 0.866, negative 1, negative 0.8666, negative 0.707, and negative 0.5. If we had one more spot there, we could go to 2 pi and we'd be back at 0. So next up, what we're going to do is we're going to work on plotting these points on the polar graph. So you can see when the angle measure is 0, our radius is 0. So what I've done is I've pulled up a nice polar graph paper here where I can write on it for us to talk about it. Now, at 0, so that 0, I'm going to highlight the angle 0. So this is kind of how I think through this. So 0 is this line here. Okay, so if I think about that line, I know the radius on that line is 0. So I'm going to just fill in a point at 0 there. Now what I've done also is you can see I made a scale on this. This is exactly the same as the graph paper in your notes. To kind of stretch things out, I decided to count by, well, 0.125. So you can see there are 8 lines moving out here. So rather than just saying this first line is 1, I wanted to stretch it out so that I could see some of these decimal points and kind of decipher between where they're located. So I have 1 way out here, and then a halfway. I just looked and I said, oh, there's 4 lines versus 8 lines, so this would be 0.5. 2 lines is 0.25. 6 lines is 0.75. So I broke that up into a nice kind of balanced scale there. So our first one was at angle 0 radians, the radius was 0. The next one is at pi over 6, and that one was 0.5. So what I'm going to do next is I'm going to think, okay, I need to go on this pi over 6 line. So I'm looking at this line here, and you do not need to graph that highlighted spot there. I'm just kind of showing you how I'm thinking about it. But then now I can see on that line, on that angle, there is my point. So my next point is located right there. At pi over 4, I'm not going to highlight this one, but you can see the same thing, pi over 4, and it's 0.707. So 0.707 is just before 0.75, so it's going to be right about in there. So I'm going to put a point right there. So there's my next point. Okay, now the other thing to keep in mind is these points are connected. So there's angles in between that we could plug in as well. So I'm kind of, this is not going to be pretty, but I'm going to try to do my best to kind of connect this and show you what this may look like as we go around here. So something like that. And then at pi over 3, it's 0.866. So you can see 0.75, and this is 1, so this is 0.9, let's see, 0.875, so point just before that, right about in there somewhere. And you know, on your notes, you don't have to be perfect, but you should have a decent idea of where it is. Okay, so we're going to go kind of like that. And then at, so this graph paper has an extra line that we're not considering here at 75 or 5 pi over 12. So we're going to go to pi over 2, and that one is at 1, a radius of 1. So I can connect all the way. So this is going to connect in a nice line, getting bigger radius, bigger radius, bigger radius, boom, all the way out to there. Now, if you look at that table we just made, it's going to come back around. So you can see that at 2 pi over 3, we're back at 0.866. So that's again back down in here. So, and then it's back to 0.707. So let's see, 0.707 is this kind of right about in here. So somewhere in there. And then it's coming down to 0.5. So I've got to go out 1, 2, 3, 4 lines. So that's going to be somewhere right in there. And then at 90 or 180 or pi, we're back at 0 right here. So it's going to kind of loop around somewhere. This is really difficult to do with a mouse to make it look really nice, but you can sort of see that's not too bad. And now, once we reach pi, something interesting happens, and this is where we have to be careful. So I'm gonna go back to our table. So at 7 pi over 6, we have negative 0.5. So let's look at where that would be located. So last week you were working on plotting some polar graphs. So when we plot polar graphs or plot polar points, we can have negative radius. So if we think about how this would look at 7 pi over 6, so I'm going to highlight 7 pi over 6 just like we did some of those other angles. So this is 7 pi over 6 right here, right along there. Okay, now I'm looking over here. This is the positive radius length. If I go behind it over here, in this area over here, that's negative when I'm going to 7 pi over 6. So if I have negative 0.5, I actually am going to land on the point I already did right there. There's negative 0.5. Okay, so I'm shooting behind that angle. So that angle is facing over this way. So now we're not considering over there. We're considering over here. And so that angle is facing towards 7 pi over 6. My radius length is negative, so it would land behind it over here. Same with the next one at 45 degrees, it's negative 0.707. So it's actually not at 45, I misspoke, it's at 5 pi over 4. So let me get rid of this one. So 5 pi over 4 is this right here. And so if I think about, oh, okay, that highlighted is my angle in the positive direction, the negative angle or the negative coordinate is going to be right behind it. So it's actually going to be, boom, it's going to land right there. You're going to just land on all the same points that you already got. If we want to check it 270 or 3 pi over 2, that was negative 1 on our table. So let's go back to that table, and we can look at, you can see, oh, at 3 pi over 2, it was negative 1. Didn't mean to click on that one. Our table, where did our table go? I'm clicking on the wrong thing. So our table is negative 1 at 3 pi over 2. So you can see that when we go on the graph at 3 pi over 2, which is this angle down here, negative 1, it's going to land up there. And so on and so forth. These are all going to land in the same coordinates. So essentially, after 1 pi, all of your points are landing in the same spot. And so we get a circle. And so this circle is located in the first and second quadrants here. It looks to like the center is right about here. So if you think about that coordinate right there where that center is, that center has a coordinates of x is 0 and y is 0.5. So 0.5. And then if you think about what is that radius length, how long of a radius do we have here? So this length here of that radius, well, it's going to be half of this total length. So it's going to be 0.5. So you're going to want to remember that because we're going to do a little math in a minute with that polar coordinate or with that polar equation, and I'm going to show you kind of how that works with r equals sine of theta, or why that makes sense. So let's go back to this. So after you've graphed it and you've got your nice circle, there's a few questions. So first question is, how many theta does it take for the plot to start repeating? Well, we saw that after pi, that we got the same exact points. They just were in the negative, so they landed on the old points. The next question is the one we're going to need to do a little bit more work on. So this next question, convert r equals sine of theta into rectangular coordinates. So put into a form that looks familiar. So what I'm going to have to do, because I'm doing screencastify, I can't expand my window in the format I'm using right now. So I'm going to post a second video that will include an explanation of that question. So I will do that in a minute. So just a couple quick things before I go into that video. But one thing is you're going to want to, in the next one, very similar type situation, you're going to plot r equals cosine of theta. See a lot of similarities, but it's not going to look exactly the same because we were doing cosine. So if I were you, I would have my unit circle out or open on my computer or Chromebook, and I would look to plot the points for that. Think about what that's going to look like in polar coordinates. Plot each point. For some reason, I gave you different graph paper for this one. It's set up similarly, but it skips over the 45-degree mark. And so these are in degrees, but hopefully you can figure that out. And then we're going to do this question about converting also with r equals cosine of theta. That will make more sense when you watch the second video, because I'm going to walk you through the r equals sine of theta steps in a minute. So then as we go on here, you're going to also think about some of these other questions, which I will talk about in the second video. So at this point, that's all I want to say, and you should be able to fill in that first page of notes, and when you're ready, start that second video.